Hello everyone. Today in this video, we are going to see how to fit a straight line using regression method. Here we call it as the method of least squares. How to fit a straight line to the method of least squares. So commonly we are given a name here, regression curve fitting using the method of least square. Here the curve is nothing but a straight line. So we're going to see today how to just fit a straight line using the method of least squares. So what is the method? How to use it? We are going to see using an example here. Okay. So first of all, we should understand what is a regression first. Okay, so it is a statistical method to determine the strength and character of the relationship between one variable y and a series of other independent variables. So what is this definition actually says is, see, for example, I'm having an equation called y is equal to 3x plus 2. Then y is the variable which we are going to find out. See, this is the variable of interest here. Okay, now I'm going to find out what is the relationship between this variable y and this variable x or a series of other numbers. So we can have this as 3x1 plus 4x2, etc. Okay, so that we are going to find out what is the relationship, what is the strength and character of the relationship between one variable y and a series of other independent variables. See here, x is an independent variable. So you have to understand x is an independent variable. So these are all the basic points you have to understand first. Then how to fit this? Actually, line of best fit using a least square method. Okay, so we are going to just imagine this is an x-axis, this is an y-axis. I'm going to just mark some points here, 5, 7, 9. Here 1, 2, etc. I'm going to mark some points here, just like a correlation. So if you would have studied correlation, similarly, I'm going to write these points. I'll just join these points using a straight line. I'll get an equation here. Okay, now I'm going to fit it out, fit a straight line. So that is called the method of least squares here. Now how to do this, we'll see. Before that, it is a straight line. Okay, line of best fit is nothing but a straight line that is best approximation of the given data. This you should understand. Now this is the method which is more accurate. Okay, so it is used to study the relationship between two variables. We'll call these two variables and x and y. It may be m and n or s and t, whichever you like, you can have it. Okay, two variables. Now, so the more accurate method of finding the line of best fit is nothing but the method of least squares. So we'll quickly move on how to just fit a straight line using this particular method. So first of all, I just wanted to show it. So how we are going to have it. So now I am calling this as an x-axis. I'm drawing it. These are all the points. Okay, now 10 and 20. For clarity, I have taken the bigger points here. Okay, now 11, 12 and all will be there. Obviously, this is 0. So I'm going to draw the y-axis where I'm having 5, 10, 15. Okay, so now in x-axis, okay, so I call it as 1 centimeter. I have taken it as 10 units. So whatever it may be, right? Y-axis, I'm taking 1 centimeter is equal to 5 units. This units may be anything, right? So that's what we are going to see now. So now how to go about? So first of all, imagine this is a graph. I'm going to mark some points. So based on this x-axis and y-axis, I'm going to mark a point just like in a graph, right? So I have marked here some points here. Okay, this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So I am just joining this with the help of a straight line now. So I'm joining this with the help of a straight line. Now, this straight line, I'm going to give a name for this. So that name, I'll call it as y is equal to a plus bx. Sometimes this will be y is equal to ax plus b also. So you must be very, very careful to find out what is a, what is b. Always which constant is with x, you should be knowing it. Okay, sometimes for confusion, okay, so you will be changing and writing, that maybe leads to a difficult sum here. Now bx, okay, you should see, say here a is equal to b here. Okay, I don't want to confuse here, right? So we'll see now what y is equal to a plus bx. Now what is this a, what is this b? In order to draw this line, we need to have two things known. Okay, now a, I should know what is a, then I should know what is called B. Then only I can fit this straight line. Okay, now A is the, so I'm going to tell you what is A and B now. Okay, so now here this is the origin. From origin where it cuts the y-axis, that's called y-intercept. If the line cuts x-axis, then this particular length is called the x-intercept. Okay, now this is called, now this particular thing is called y-intercept is A. This is denoted by A. Okay, so now this distance. Now you see how slanting this line with the x-axis. Okay, now the slanting which will give you the value of B. Okay, so now B is nothing but, I'll call B as slope here. Slope is measured as tan theta, or sometimes they'll call it as tan alpha. It is nothing but tan value of the particular slanting here. Okay, now I'm going to show it now. You see, now imagine this is the x-axis. Okay, now, and this is the angle theta. Now B is equal to tan theta. Okay, now the particular value, so if I write it in points, then I'll take this as for B. Okay, now B is usually tan theta. So I should know what is A and what is B. Then I'm going to proceed here. Okay, now this is called the slope of B. Okay, now slope is B, A is the intercept. So we want to find out A and B to fit a straight line here. Now, how to fit a straight line? So we should be finding out A and B here. There are two methods how to find out A and B. One, I'll use the equation. Another one, I'll use a direct method. Both methods we are going to discuss here. Okay, so now we'll move on to the an example here, fitting a straight line using normal equations method. So we are going to see the first method, which is called the normal equation method. What is it? How to do? We'll see now, right? So now the equation of the straight line already we know. It is of the form y is equal to a plus bx. Sometimes this will be y is equal to b plus ax also. Sometimes x is equal to b plus ay also will be there. Whenever it is asked, whenever some people will ask, both you should find it out. Okay, now we are dealing with the first part here. Then if they ask x, and you are going to replace x and y, and you are going to find it out. Okay, now how to find out this? Okay, now you see here y, A is there and B is there. Very carefully. Now the normal equation is sigma y. It starts with y. Now if it is y, it starts with y. If it starts with x here, I should write sigma x. Okay, that alone you have to remember here. Very important one. Okay, now NA plus B into sigma x, then sigma xy is equal to A sigma x B into sigma x square. If this equation is x is equal to A plus by, then this will be changing into sigma x is equal to n of A, no problem at all, plus B into sigma y. Then this will become sigma xy as usual. Then this will be A into sigma y. Then it should be B into sigma y square. We will be seeing this also in a thing. Okay, now for this one, okay, this equations. Okay, now for this one, this equations, you should be very, very careful while you are doing this. Okay, now this is so we are going to deal with this y is equal to a plus bx only. So we will be doing the sum here. Now this is a sum which is given. Fit a straight line y is equal to a plus bx to the data by the method of least square. What I'm going to do is here, x is given, y is given. Then I'm going to draw one tabular column which says x, y, x square and xy. You must be very, very careful. See, whenever there is x here, I should have x square here. When there is y here, I should have y square here. You must be making a note of it here. Then I'm going to fill up what is the value given here. I have filled out here. Then x square. So 5 square, I'm going to write it as 25 here. 10 square, I'm going to write it as 100. 15 square, 225. 20 square, it is 400. 25 square, it is 625. Then I'm going to multiply this x and y here. I'm going to write it in the next column. So now 5 into 16, which gives you 80. Then what is the next number? 10 into 19, which gives you 190. 15 into 23, which gives you 345. 20 into 20, which gives you 400. 25 into 30, which gives you 750. Then I'm going to find out the total for this. Okay, this column is 25. Okay, I'm sorry, 75. This column is 108. This column is total at 1375. This column, it is total 1765. Then this total I'm going to substitute in the normal equation and finish it off. That's all right. So suppose I'm going to write the normal equations once again here. You see, these are all the normal equations, two normal equations. So here, sigma y, what is that? It is 108. I'm going to write it here. Then what is n? N is 1, 2, 3, 4, 5. 5 is n. Then what is b? I'm going to write b as it is. What is my sigma x is 75. So first equation is over. Similarly, I'm going to write the second equation here. Now I'm going to solve these two equations. Okay, so in any method you like. So we are dealing with three methods. One is called the elimination method. Okay, another one is substitution method. Then another one is cross multiplication method. Okay, so now, so whichever you are comfortable, you can use this. If you do not know how to solve these two linear equations, I have put one more video for you to help it. You can see. So I am putting it in the description box. You can just check it out, how to solve the linear equation, and come back here once again. So I'm going to solve this using this elimination method only. Okay, so now elimination method, how to do this. So I'm going to make this A and B as equal here. So what I'm going to do it here, I'm going to multiply. Okay, so multiply the first equation by 15 so that it will become 75. So my A will be same so that I can subtract it. Okay, now first equation I'm multiplying it. Okay, now this I'm multiplying by 15. So 15 into 5 gives you 75A. Then 15 into 75, which gives you 1375. 15 into 108, which gives you this value, right? So first of all, first here it is already 75A, it is there. I'm going to write this particular thing here as it is. Then I'm multiplying the first equation. I'm putting it down here. Okay, now first equation, this one I've written here. This I am multiplying by 15. I'm writing it here. Okay, yeah. So now I have multiplied this 5. Then I'll get this one. And I multiply this by 75 and 15. I'll get this one. And I multiply 108 by 15. I'll get this one. Okay, so now I'm going to subtract this now. Okay, I'm going to subtract this, change the sign, change the sign, change the sign, subtract it, 1375, 1125, which gives you 250 here. Then I'm going to subtract these two numbers, 145. I'm going to find out what is the value of B here. Okay, B got 0.58. So I'm going to substitute in any one equation to find out A. Okay, that's what is this. A is equal to 12.9. I got it. So I'm going to write this here. Okay, so Y is equal to 12 points. So A I got and B I got. I'm going to see this A I got it, B I got it. I'm going to substitute in this and I'm writing this is the equation of the best fit. Okay, line of best fit. I can write line of best fit or equation of the line of best fit. This is how we will calculate. Okay, so the only part you have to understand is here how to eliminate one variable and find out the value. So you can see the video which is already been done for you in 3 methods. So instead of elimination method, if you feel it is little tough, you can go for cross multiplication method and you can have the substitution method also. Now, what happens if I want to find out the other equation, x is equal to a plus by, if it is given? So you see this particular thing, this alone we are going to change it. Okay, that's what we are going to do in this second one. So now I'm going to find out the line of best fit for x is equal to a plus by. The same method I'm going to do it once again. So you see, same procedure, instead of x square, we are getting y square here. Okay, then I'm going to substitute in the normal equations. I'm going to finish it off. Okay, the same method. Only thing you have to change it here is y square, and you see the normal equation here. This is what is very, very important. Okay, you have to see the normal equation which changes here. I'm going to write it down, the normal equations, and we are going to finish it off. Okay, this is what you have to remember. Okay, previously you just see here. I'm going to show it here instead of the sigma x, and you should be having sigma y in the previous. Okay, instead of the x and y, we are changing here. This particular thing alone, you have to note it down. Okay, because of this x, I have changed the normal equations. The normal equation alone will change. The other procedure is same here. So once you finish it, just like a previous sum, you will get this value. Okay, this is fine. This is called the using the equations, normal equations method to solve this. Then what I'm going to do is I'm going to have a direct method also. How to find out? See, what if years are given for x? No, if it is given as 1989, it is very tough for me to find out the square, etc. So in this particular thing, what I'm going to do it here. Okay, so we'll see here. This is what is given. Years are given. So it is very tough for me to just subtract, add, and multiply and all. So what I'm going to do here is I'm going to follow a smaller method here. So this is what is X. X is given 1996. So I will take some middle number here. I'll subtract it from all the numbers and find it out. That's all. It's finished, right? So what I'm going to do is X square. Here it is very bigger one to find it out. So it will be, my number will be very big. So what I'm going to do it here, I'll take this X here, 1996. Then 1998, I'm going to take it as just like an assumed mean. I'm going to subtract it from each value. So I'm going to omit this value. I'll take this value as X and finish it off. It is easy, right? So just like this, right? -2, then I'm going to multiply this, right? So what I do is I'll take the one central value. I'm going to subtract it, make this X as smaller and proceed. Okay, now we are going to see what is called the direct method here. Instead of using the previous method, I'm going to find it out. The direct method here, this is the formula to find out B here. Okay, B will be given as sigma xy minus sigma x, sigma y divided by n, and sigma x square minus sigma x the whole square by n. Similarly, formula for A is equal to y bar minus B into x bar. X bar and y bar are nothing but mean. Okay, mean of x and y respectively. So you should be understanding this. Okay, now previous method or this method, both are same here. Then note down here. How to do this here? It is very simple. Now fit a straight line A plus bx to the data by the method of least squares. This is what I'm going to find it out. Now I found out mean here. For x value, I found out the mean. Similarly, for y value, I am finding out the mean. Then I'm going to substitute in the equation. That's all. It is finished. Very, very simple. Just I'm going to show the tabular column here. Now, what is the tabular column here? It is 1, 3. Then I'm going to square it. Okay, now what is x square? 1 square is 1, 3 square is 9, 4 square is 16, 2 square is 4, 5 square is 25. Similarly, x, y, I'm going to find it out just like a previous one. Here, I'm finding the total here. Then I'm going to substitute in the formula to find out what is the value of A and B. So by substituting in the formula, I'm getting the value of B as 0.1 here, and I'm getting the value of A as 3.3. Then I'm going to substitute here. Equation of the best fit is equal to y is equal to A plus bx. Now 3.3, and here the value of minus 0.1 for the B. Okay, now it is nothing but a direct method where I'm finding out B directly and A directly and substitute here. Now you see this A is calculated using the mean. Okay, so previously I got the mean as 3 here. I got the mean as 3 here. Once again, I'm going to tell you. So the same tabular column, after finding out these total, find out the mean here. Mean I found out, and I'm going to substitute here in this formula. This is the direct method by which we are going to find out the straight line equation by the method of least squares. Okay, there are two methods you can follow here. One is direct method to find out the value of A and B. Other one is use the normal equations and elimination method by which you can find out A and B and substitute. In both the methods, we are going to find out the value of A as well as B to just substitute in the equation. Okay, thank you very much for watching this video. So if you like this, kindly subscribe and come again for another new video to come. Thank you very much. Have a good day.